Today is Wednesday, August 27th, and we're going to do physics. I mean, this is a physics class and all. It'd be kind of surprising if we didn't do it. Okay, so first off, it is Wednesday, 2 days in, and I've already gotten a couple questions about displacement and the homework. Congratulations, good job. Yay for starting the homework on when you should, doing a little bit each day. Let me give a hint or 10 too with this, and then actually I want to make sure that what we've been doing, what we did before, does carry over, that knowledge has a transfer over to the context or the sort of problems that I'm going to ask you to do on the homework quizzes and exams. So let's start with this. Let me strongly encourage you, a really good skill that you can go back to. It's way back to, for God's sake, like third grade skill. Hopefully that's solidly, deeply, profoundly inside you is the number line. When talking about displacements, a number of students, as I said, struggled with finding displacements. Let me suggestify that oh, for God's sake, that you draw a number line and identify places along it. The numbers on the number line are the positions. The differences between those positions are the displacements, and the absolute value of those are the distances. So, for instance, oh, right, yes, and also second, what's origin mean? No, origin does not mean starting point. Here's my hand. Here's x equals 0. Where's the origin? Origin's here. You define, the origin is your reference. The origin is you're making up numbers to identify, to describe something. Wherever your x equals 0, that's the origin. It's not your starting point. So, suppose, for instance, here's a big hint for oh, for God's sake. The very first problem in the test had you put a cinema somewhere. That's a house, so for God's sake. Here's a cinema. Oh, it doesn't look like a cinema. And had you put a person somewhere, some distance away, and then there's the person's house some distance away from that. Well, if I define the person as the origin, here's how to calculate positions and displacements. What's her initial position? 0. Duh, in this case, the initial position is the origin. If she walks home, what is her final position? -3, whatever the units are, miles or whatever. What is her displacement? -3. Oh, for ball's sake. Google form. Question B. If Alice walks to her home here, what is her displacement? Chop, chop, quick like a bunny. I don't want to spend all day on. Good. Yeah. Okay. So if I say x final equals -3 whatevers, x initial equals 0 whatevers, x final minus x initial equals -3 minus 0, which last I checked was -3 units. Now I want you to practice associating all of your answers and taking 2 seconds. You spend 5 minutes doing a physics problem, take 2 seconds to think about what it means. What did I say displacement is? It's not just difference, final minus initial position. It's also how far and which way you go, right? She goes 3 units. Yep, that's 3 units in the negative direction. Bam. Yeah, this is the correct answer. What if she walks, no. That's not what I want to say. What if the origin is located somewhere else? What if I said the origin is at the cinema? Google Form C, what's her initial position? Look at the origin that I defined. Initial position is not at 0. And her initial position is not at the cinema. Look, here's where she is. She's not at the cinema. The cinema's over here. Again, let me remind you. The initial position is where she is at the start of the problem. Bam! Her position is negative dose, -2 units. You look at where is she? She's not at the cinema, right? She's not at position 0. And again, let me remind you that I define origin as being where do we set x equals 0? It has nothing to do with, it is not the same thing as where does object start. That is not origin. Not in a physics sense, not in a math sense. X initial here for if I have a cinema origin, blah, -2 units. What's her final origin if she goes home? Google Form D. She goes home. Okay, I'm getting more surprising answers here than I expected. Where's home? What's its position? If she goes home, XF is just where that is. You just look at your number line that you made up and say, the number line shows me the position values. So what position means? Now, follow-up question. What's her displacement? Question E, what's her displacement? What is -5 minus -2? Question E, what is her displacement? Check your subtraction carefully, please. Okay, so a significant number of people are subtracting incorrectly. Let me remind you that -5 minus -2 and -5 minus 2 are very different numbers. What's -5 minus 2? -7. -5 minus -2 cannot also be -7. If I subtract a negative off, that's the same thing as adding it. -5 plus dose. -3 units, whatever the units of measurement are here, is the correct answer for E. Okay. Reflect on this now, my grasshoppers, to achieve physics enlightenment. Did the distance she go change 1 bit? Reflect on this. Did the direction of motion change 1 bit? Where you put the origin affects your coordinate, your position values, but your displacement, how far and which way you go, always stuff to the origin will cancel out. Your displacement is your displacement is your displacement. How far and which way do you go? You can get it by subtracting whatever your coordinate positions are off each other, final minus initial, but don't get so hung up on numbers. You can sometimes just look at the darn problem. I didn't really even need to write numbers down here. I could see she 3 tick marks on the number axis. Whatever these are, going from initial position back home is 3 units left, -3. Questions about this? No, turn to your neighbor, explain to them what the hell Tucker just said and why'd he say it, and then ask me a question real fast. Okie dokie, time's up. What you confused about? Where are you confused? Where are you stuck? What's hard? Questions, follow-ups on this. Gesundheit. Nadie? Nobody? Nichts? Okay. So now into material proper today. Nope. Real fast. Yester class. Half of my 430 section, and I didn't count, but my guess is way too many people screwed up on finding slope. Let me remind you, let me briefly start off showing you here how to slopeify this sucker. I'm going to find the slope. I'm going to show you how there are multiple correct ways to do it, find the slope at time 10 seconds. Slope is the tilty inclination of the graph. All this time interval has the same tiltification. Right? So I'm going to pick any 2 points on the graph, but I think it's easiestest to pick the 2 furthest points on the graph. It's easiest to see where they are. What's my rise when I go from position 50 to position 100? 50. My displacement is 50 meters. Positive or negative? Positive. You're going in the positive direction from positive number to a positive number. What's my run? 20 seconds. So I would say my rise over, wait, that wasn't loud. Y'all agree that this has a horizontal run along the horizontal axis of 20 seconds? Yeah. Okay. So slope formula, rise divided by run, 50 meters divided by 20 seconds. Slope, which is velocity, average velocity in this time interval, is 50 divided by 20, which last time I checked is 2.5 meters per second. Okay. Again, les formula, rise over run, does not use y divided by x. You do not plug in freaking 75 minus x. You could plug in 75 minus 50, the change in the change in the graph, the change in the function graphed, change in position divided by the change in time in that time interval. But it's not 75 tenths. It would be 25 tenths. Delta x over delta t. Turn to your neighbor and tell them how to find slope real fast, then ask me a question. 1 minute. Yeah, but it depends on how the graph is. But if it's easy, then you can write over and simplify equation. Yeah, but if it's confusing, you got to do that equation. I forgot. Yeah. He said I think it was y equals y2 minus y1. Okay, question me. If this is weak, ask, seek it out, make it part of you. Don't let this go. This will screw you over if you can't find slope. You're going to be taking slope and getting even crazier with it today. No? Really? No one's willing to ask? Good. That's correct. Which is rise, y2 minus y1 says how much my vertical coordinates changes. Over run, x2 minus x1 is how much that horizontal coordinate changes. Good. Okay, follow up Google form. What are we on? E already? F. F that. Everyone, real fast, chop, quick like a bunny. At time 22 seconds, I'm located at x equals 100 meters. Super fast. Tell me the slope at time t equals 22 seconds. Chop. Hmm? Yeah, the question is, what's the slope at time 22 seconds? Hey, my dudes, still got more than 10% of you missing this. It's a flat line. It's a horizontal line. What's the rise, dudes? Zero. And zero divided by any run is zero. Slope is zero, man. Look, at 22 seconds, is your position changing? At 20, I was at 100. At 21, I was at 100. At 22, I was at 100. 23, I was at 100. If I stay at the same place along the room, what's my velocity? Zero. On a position time graph, you get a horizontal position line, zero slope, zero velocity. And again, the goof that those 10 people are making, I guarantee it, is you are dividing y by x. It's not y over x. That's not the formula. That's not the nature of slope. Look at how the function is changing. Slope is change ratio. I'm not changing. I'm not going up. I'm not going down at 22 seconds. Yeah? Okay. Last chance for questions. Okay. As I said, this is big today. Okay, now I'm going to give you a whole bunch of things that are designed to bridge between the theory you've got and being able to apply it to this, to apply it to the homework, the quizzes, the your mama, whatever. Okay, so what? Let's see if you can do this. These should, after what I just said, should be straightforward. G H. Ready, set, go. 1 minute. Draw a number line if you need it. I'll zoom in. You guys can't see, can you? Oh my God, so many correct answers. I'm so happy. Hmm. People screwing this one up are different than the people screwed the previous one up. Hmm. That's odd. Like, really? Hey, that's great. Means the previous people who were screwing the last one up maybe learned something. Good, good, good. Well, maybe. Okay, let me encourage you strongly to draw a damn number line. Every one of you, draw a damn number line on your paper. It doesn't take long. And show these displacements. I'll give you a hint. More people are wrong about this than they were on the previous thing. So far I'm counting 27 mistakes. Oh, 28 mistakes. 29, 30 mistakes. Don't be one. I mean, you're not a mistake. You're all perfect exactly as you are, but fix it. All right, time's up. Here's how to draw on a number line. I'm going to identify my initial position. Initial position, I sketched out a number line with lots of room. Initial position is 20. Bam! There's where I start. There's this cute little head. He undergoes a displacement of delta x equals 5 meters. Where does that put him? If I start at 20 and move right by 5, I end up at ding, 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 ding. Shoop-a-doop. Okay, then I displace again by how much? So I walk which direction? How far? 15 meters. Shing, ding, 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 ding. Where am I ending? What is my final position for the second part? 10 meters. Answer for H was 10 meters. Total displacement. What's my final minus my initial? If I started at x initial equals 20, x final equals 10, what is final? Final minus initial? No. Negative 10. Negative 10. All right. Okay, and again, we interpret what is the meaning of displacement, how far, 10, and which way, in the negative direction. I started here, I ended here. I've gone from 20 to 10. That's in the negative direction along a number line. Push this, push this. Y'all, I'd like to see 100% on this by the time quiz and exam roll around. This is subtraction. Number lines, you could do this. Everyone, every single one. Yes, question.
I understood it like how many units did this person move over this course of time, rather than how many units did this person now to when you finally finish.
So total displacement is where do you end minus where do you start? That is different from distance covered. That's fantastic point. Hey, I'm gonna move. Here's my initial time. Here's my final time. What's my average velocity? 0. My total change in position is 0. I could show mathematically that the average of this velocity and this velocity, I'm averaging a positive and negative number, and they canceled. But if you just look at the average velocity, when you return to your starting point, the average velocity, how much did my position change? Didn't change by 3 meters just there. I'm in the same x final as I was at my x initial, 0 meters displacement. Distance covered is much more complicated to calculate in general. The distance covered is much more difficult to calculate than distance between 2 points. We're going to use distance between 2 points, always in here. Unless I specifically ask otherwise for distance traveled, then you got to think about it. Hey, what is the distance traveled here in this case? The distance traveled. If you put a odometer on him and looked, how many meters do his feet move? First he moves 5 meters, then he moves 15 meters, sure in opposite directions, but the distance, total distance accumulated by his feet would be 20 meters. I'm never gonna, I don't think that I ever ask about total distance covered mathematically as hell. We're not gonna do that. Okay. IJK? Huh? Thank you. Gracias mucho. Molto bene. Shay? Merhaba? Do this together. It should be louder in here. Come on. Let me hear you talking about the physics. The positions are the same. Positions of displacement are the same in the previous, by the way. I'm not trickying. Hmm?
The initial is 20.
I would say x initial becomes 25 for the second interval. I start at where? 25 meters from origin. Yay, correct answers. Boo, incorrect answers. Check yourselves, check each other. Okay, I've got twice as many wrong answers as right answers for part J. Read carefully. Read carefully. Displacement divided by time interval. Check yourself. Okay, time's up. Question I. How do I do this? Velocity is defined as displacement divided by time. I tell you the displacement is 5 meters. What does 20 meters have to do with the displacement? Nothing. You should not use 20 meters. You should not use 25 meters. Velocity is change in position divided by change in time. Not where you are divided by time, how you have changed with respect to time, right? I'm sitting out here at 101st Avenue, 43rd Avenue, whatever. Say my position is negative 43 streets and the Phoenix axes. I'm just sitting here. Do I divide 43 streets divided by an hour to find my velocity, just sitting here for an hour? No, I'm just staying here. My velocity is 0. My 43rd Avenue is not becoming 42nd Avenue, becoming 41st Avenue. So you don't just divide your position, you look at the displacement. The displacement is 5 meters. Okay, and displacement divided by what? Divided by the time it takes to affect that displacement. I tell you, from time 0 to time 10, how long is that? Well, mentally, if I can subtract 0, I could get 0, 10 minus 0 is 0. Correct answer for part A is 0.5 meters per second. Huh? Most people got that. I'd like that to be everybody. Look at your definitions. You need to know your definitions, is one thing. I suspect that some people look and their eyes glaze over when there's an equation on the board. You can't do that in physics. You got to actually pay attention to what I'm saying and what it means. Part dose. It's the same darn physics, but here only a few of you really ultimately are getting this right. Let's dive into this. What's your darn displacement in the second interval? How long does it take to displace that 15 meters in the negative direction? 5 seconds. You don't start at time 0 again. My stopwatch didn't reset itself. The difference between time 10 and time 15 is 5 seconds. 15 meters per second. 15 meters in the negative direction divided by 5 seconds is 3 meters per second. Which way have I gone? Negative direction, negative 3 meters per second. You don't like it? You don't like it? Tell me why. Okay, so what's the formula? Can you tell me the formula for velocity? Rise of what? What is rising? We don't have a graph right now. Time is not the rise. Time is on the horizontal axis, usually, almost always for this class. Go back, look at your notes. Look, it's like, how do we measure speed? Miles per hour, right? Here's the miles. Here's the hours. Hours aren't on top. Okay, so what's delta x mean? What does it tell you? How your position has changed, your displacement. Vocab word. Know this. If I go a displacement of negative 15 meters, bam, you're done, negative 15. Over what time interval? How has time changed? I'm not starting from t equals 0 now. I started at the end of the first displacement, right? I didn't there's nothing about resetting a stopwatch. From 10 to 15 seconds is a time interval of 5 seconds. Okay, turn to thine neighbor and explain to them what the hell just happened. Because as again, 2/3 of you missed this. But you gotta make sense of this. What? Hold on. Initial and final what? Over the initial and final what? For the second displacement? But that's y divided by x. That's not the formula. That's not the meaning of slope. Slope talks about how up do you go for each over, not where you are, divided by what your stopwatch says. That's not what v is. Question. Speed, your speedometer in your car measures speed, and nobody ever observes the speed of negative numbers. I didn't say velocity is never negative. Speed is never negative. Good question. Okay. Next. No. The room is quiet in a way that tells me that people are confused and expecting to understand it if they just sit still enough. Physics is not a velociraptor. It will bite you if you don't move. T-Rex, whatever. I haven't watched that movie in 25 years. Okay. And physics is not something that you can expect to just come to you in a flash. You have to work at it, damn it. Tell me where you're lost and I'll give you a hint to move you forward. Or maybe I'm misreading things and y'all are perfectly happy here. Please. Absolutely. Just part 2, right? Part 1's easy. Okay, so part 2. Velocity is defined as how does position change divided by how does time change. What did I tell you in the problem about the second displacement? I tell you how does position change? Right there, right there. It's in the problem. Numerator is negative 15, bam. Are you okay with that? So it's just the time that's screwing you over. Now, again, I am going to define displacement divided by the time it takes to do that displacement. I start my stopwatch when he's at, I guess, 20 meters. This is saying that my stopwatch hits 10 seconds when he's finished moving the first 5 meters. Then when he starts to move backwards, well, I didn't reset my watch. Time 2 equals, not delta time, time 2 equals by time, not time interval. Time is 15 seconds. Time at that clock reading is 10 seconds. If I had said a displacement delta x1 equals 5 meters in a time interval of 10 seconds, and then said undergoes negative 15 meters displacement in an interval of 15 seconds, then the answer would be a negative 1. But the time, the separation between the first phase of motion and ending the second motion is 5 seconds. I start at 10, I end at 15, that's 5 seconds. Better? You got to pay very careful attention. You are probably noticing very careful attention to what I say. Physics is the science that tries to understand absolutely the entire damn universe, from the smallest atom to the largest galaxy and everything in between. Physics has no room for ambiguity. We have to learn to be very precise about our language. Precision of language begets precision of thought, begets getting the right damn answer. So read carefully. Each word means one thing and one thing only. And I say what I mean. If, by the way, if I ask a question, if I ask something truly ambiguous, I will give you a free point for it on exams. I claim that every one of my questions, I use language consistently. And if I screw up, I'll give you guys the benefit of the doubt. Merry Christmas. Okay? Just so you know. What about the third one? What's the average of -3 and +1/2? Something like -1.5? No. Guess what? You can't do that. You can't do that. You can't do that because they're different time intervals, and you can't just average two numbers, two velocities, two rates as if they're ordinary numbers. For instance, I drive for an hour at 100 miles an hour, as I usually do on the freeway, and then I drive for 5 minutes. I get off the freeway, I drive for 5 minutes at 2 miles an hour. Yeah? How far did I get? About freaking 100 miles, right? I'm sorry. No. That's a bad example. I'm making this up on the fly, and that's going to go somewhere. Let me use the numbers given in here. I've got a perfectly good problem. What's my total displacement that I said again? Previous slide. What's the total displacement? -10 meters? What is that? -0.7-ish? 0.667? 2/3? You can't see that. I'm sorry. Okay, did you hear it? Okay, no, that's not halfway between -3 and +1/2. For rates, unless you are going an equal amount of time, don't just average the two numbers. You've got different denominators. If you know what a weighted average is, you're allowed to do that. But in general, you can look at how far do you go, divided by how long did it take to get there, bam, you're done. Okay? Okie dokie pokey pony. Graph me. Graph it, rather. Don't graph me. Try to be somewhat precise about this, okay? Make a sketch, a graph of position as a function of time, and can you graph, let's find out, can you graph the value of velocity as a function of time? Where does it go? Don't look at my answer. Do it yourself. Do it yourself. I'd have you put this in the Google form, but it's kind of hard to type a graph. Hashtag sad, hashtag not #1 in innovation. No, you don't like it. Your eyebrows really don't like it. Talk to me. Which graph position? Okay, so what does this say? Is this position? So what does it mean to displace by 5? You can go back 2 slides too to your answer about what is the position at each time. So if I start at 20 and walk 5, where do I end up? Yeah. After how many seconds do I get there? After 10 seconds, I've walked 5. Ding, 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 ding. Good. Damn it, my axes are tilted. Ugh. Okay, even if you're not done with the second, take a quick look at the first. I expect, since we haven't really done velocity graphs, should be able to graph anything, but we haven't practiced it, so screw it. Just question the first question, which isn't going in the Google form anyway. Did you get this? I start at 20. The next time, the next displacement interval brings me 5 meters, displaces 5 meters to 25, just like 2 slides ago. And then I displace negative 15 meters. That ends up at positive 10, yeah? All right. Did you get this? Great. Real fast, let me make a couple of points. Position time graphs. How do we interpret the slope of a position time graph? Velocity. Hey, my slope is up. I am moving in the positive direction. Hey, my slope is down. I am moving in the negative direction. Positive slopes, positive direction of motion. In this case, I'm moving, say, northward, or he's not moving upward. Oh, maybe he's on a building, whatever, I don't know. So he's moving in the positive direction, and he's moving in the negative direction. Yeah, from a big number, from a big positive number to a less positive number in the negative direction, downward, southward, whatever. How could we interpret the magnitude of this slope? This is shallow, that's steep, yeah? What's the magnitude of the slope? The absolute value of the slope. What does the slope of position represent again? Slope of position is velocity. So what's the absolute value of velocity? It's vocab word, speed. Speed, yeah? Shallow slope, slow. Steep slope, fast. This will be on your quiz, by the way. This will be on the midterm. Close to axis, what does that mean? How do you interpret if a point is close to the horizontal axis on a position graph? What does that tell you? You are close to wherever the origin is. What does it mean if the position values are far, big numbers away from 0? You're far from the origin. Okay, so for a position graph, this is far away from origin, close to origin, at origin. This is slopey up is positive velocity, slopey down is negative velocity, shallow slope, slow velocity, steep slope, fast speed, I would say. Okay? Okay, now let's make a graph where the values of the graph as a function of time are the slopes of the other graph. What's the slope for the first 10 seconds? 0.5. Bam! There's the first part of your velocity graph. It's actually really simple, right? If you have a steady slope, you're not changing your velocity. If you're not changing your velocity, you got a horizontal velocity value line. It's 0.5 and staying 0.5. Bam, that's the velocity, the first part of the velocity graph. Okay, so then I change my velocity. What's my velocity after a little bit? After time 10? -3. So bam. There's the graph for this problem. You can now draw velocity graphs. What is the slope at this time interval? What is the slope in this time interval? Those values are the height of your velocity graph. No, you don't like this. Ask me a question. I'll give a second. Ask me. It's a new thing. We haven't done velocity graphs yet. Oh, we're gonna do lots of them. So ask me. I see lots of glazed eyes now, for realsies. Yeah. Uh-huh. That's why I labeled this t and this v. Or time t, and yeah, good, yeah. Good. Yeah? No. Yeah. Because the velocity changing instantaneously says that in an instant, I go from one direction to the other direction much faster. That's actually non-physical. Nothing with mass can instantaneously accelerate. However, I say, for the sake of keeping it doable without advanced calculus, screw that. I'm going to simplify and say, first I'm this value, then I'm that value. And vertical lines don't belong on graphs, unless you're an axis. One last thing, average velocity that we found before, that's the slope of that line. If you connect the initial and final, find the slope of him, that's the slope of the, what do we call that, a secant line? This is the sucker that has the slope, god damn it, what do we find? Negative 0.67? And I want to emphasize again that that is not the average of 0.5 meters per second and -3 meters per second. That's not the simple average, the weighted average, if you know what that is. No other questions? No other questions? Really no other questions? I mean, maybe the best thing to do, because I smell that there are questions in your heads, maybe the best thing to do is move a little forward and see more examples of this. Okay. I'm gonna walk through this quickly, how to do a difference in time problem. I drive 10 miles at 20 miles an hour. I drive no, it makes sense. I drive the same distance, the same distance. It sounded right in my head when I said I drive with an average speed. I drive the same distance. If I went twice as fast on average, how much time would I save over a commute of 10 miles? Can you picture it? So this is, I'm about to show why it's so stupid to speed so much. Zooming around cars. No, it doesn't actually save as much time as you think it does. I'm doubling my freaking speed here. How much time does it save? Okay, well, here's the thing. Here's the question. The difference in time, how much time would I save, is a subtraction. If I want to know the difference between two times, first I got to find them. Time 1 equals, maybe I'll say time 20 miles per hour times 40 miles per hour. If I go 10 miles, and each hour I was covering 20 miles, right? 20 miles per hour means in 1 hour I cover 20 miles. How long does that take? 30 minutes, right? Half an hour at 40 miles an hour is 20 miles. At 20 miles an hour is 10 miles. Half an hour. How do you get that, by the way? Distance over velocity equals time. That's just a rearrangement of delta x over delta t is v. Yeah, you see that? Algebraically. Okay, likewise, we could plug in if we got 40 miles. This isn't demonstrating. This isn't demonstrating. I should have picked numbers closer together because people don't actually double their average speed when they speed. Talk about going, 10 miles over is really zooming past, not going 80 on a residential street or 160 on the freaking highway. That doesn't happen. I mean, hope shouldn't. Okay, so how much do I save? I find the time to go at this speed. I find the time to go to that speed. How much time did I save? 15 minutes. I'll give you a problem like this in the homework. Make sense? Easy peasy? Oh, okay, something else. Okay, let me ask you this now. We're going to go to one last thing, a changing speed on a position graph. How do we view speed on a position graph? How do we see velocity or speed on a position graph? Slope. So what happens if I speed up on a position graph? Slope does what? Slope is not positive. Slope changes. It's not that it's steep. If I move fast, my position slope is steep. If I move slow, my position slope is not steep. If I move faster, my steepness is changing. Here is speeding up while moving in the negative direction. Look, slope is down at every point. Slope is down, graph is decreasing, yeah. But isn't the line getting steeper as you go? So how do we see speeding up? We see speeding up if the line is steepening. The position versus time is steepening. Steepness indicates speed on a position graph. So spurring, getting steeper, indicates speeding up. What would getting shallower indicate? Slowing down. What would staying the same slope indicate? Moving with a constant what? Speed. I would call that uniform, steady motion, unaccelerated motion. Does it matter, by the way, that I have positive positions here? I say that he's moving leftward. Does it matter that my x's are positive numbers? No, it really, really does not. If my x's are negative numbers, if my x's are positive numbers, the position is relative to a different origin, perhaps, but my motion doesn't have to do with position divided by time. Velocity and acceleration relate to changes in position, displacements divided by time intervals. Exactly the huge point of the first half hour of this class. Displacement is origin independent. I want to hit on one last topic. One last topic. I want to have you guys review what we said because we've done a fair amount. And then, oh, what the hell? I'll let you go 5 minutes early, okay? If I sense that you're actually discussing with each other, just like the crazy dairy farmer discussed with each other, okay? Hey, love that pun. But no, I just want to look at VT graph for a sec. We'll talk about doing a problem with it later. Don't review just yet. Take a look up here. Here is a velocity graph without horizontal functions. What happens if I change my velocity? What does that look like if I graph a velocity graph? What does it mean to have a velocity graph with points at various places? Let me ask you this. At time 1 second, how fast am I moving? Google form. Question L, at time 1 second, what's my velocity? Graph. Yes. No, the answer Hxing2 is not a graph to draw. It is a number. Again, la pregunta, the question, is what is the value of my velocity when time is 1? Okay, time's up. 8. 8 meters per second. Here's how you read a graph of quantity x versus quantity y. You look at when x is blah, y is blah. Right? At time 1 second, my velocity is 8 meters per second. Is that fast, by the way? Yeah. Is that fast? It's fast. Here's fast motion. Psh, come on, no erasy. At time 2 seconds, just out loud, how fast am I moving? 4. For what? Be precise. Meters per second. Good. Okay. That's medium fast. At time 2.5 seconds, how fast am I moving? 2. What? 2 meters per second. That's kind of slow. Even I can walk that fast. How fast am I moving at the instant time t equals 3 seconds? I am not moving. I am at rest at that instant. What is the sign of the velocity here, and here? Positive. Sign of the velocity. Velocity 8, velocity 4, velocity 2, those are positive numbers. The slope of the velocity has a negative sign. Don't get those confused. The values of velocity are shown by the height on the velocity graph. This isn't a position graph anymore, okay? So these are positive velocities. What does positive velocity tell us? The sign of velocity, like the sign of displacement, tells us which way are we going? Are my x values increasing? Right? If the slope of position is positive, of velocity positive, slope of position tells me am I increasing or decreasing my x values. So the fact that these are all positive velocity numbers says that I'm moving in the positive direction until I hit at rest. I'm going to call this, I'm going to just say moving upward, for instance. And of course, there is not moving at all. What about negative velocity numbers? Duh, right? Making sensey? If the values of velocity are -1, -2, -3, -4, if the values of velocity are negative, that means I'm moving in the negative direction. Yeah? Okay. I start at time t equals 3, I'm not moving at all. What is happening to my motion here? Am I speeding up or slowing down? You can't slow down from at rest. I can't slow down any further. I'm 41, believe me, I would know. I gotta slow down every year, but not when I'm at rest. So if my velocity is getting further away from the origin, this is speeding up. If my velocity values are getting closer to the origin, I'm slowing down. If my velocities are on the origin, I'm at that instant stopped. Yeah? Huh? We're going to play with the slope of velocity later. One more vocab word. Besides fast, slow, speeding up, slowing down. This is not just a point where I'm at rest. I was moving upward. I'm about to start moving downward. Anyone know how you describe that to a 5-year-old? You were moving in one direction. You're about to start moving in a different direction. Turning point, turning around, exactly. 100%, 100%, very good. So I could describe this as at an instant at rest, but not just that, also turning around. Okay. Absolutely vital, important, powerful, crucial, I will test you on this skill, is to be able to take graphs and interpret, as well as numbers, and interpret in English. Is this fast? Is this slow? Am I above or below the origin? Am I moving upward? Am I moving downward? Am I speeding up? Am I slowing down? If you look at this, you can describe this completely and concisely as I move at first quickly in the upward direction, I slow, reach a turning point, and then speed up in the downward direction. We'll get there. I'll get each and every one of you there, or you'll fail. You must all be able to do that. But understand and put in ordinary words, position and velocity graphs. But now we have 7 minutes left. Please turn to your neighbor. 2 minutes. Review. You can't review everything. Tell them 3 facts from today, preferably 3 things you learned in your own words. Ready, set, go.
One's average velocity. Second, that's has to find the difference of the second that I'm just dividing and what does it change is like what is there just as a oh, yeah, where you can't go. Yeah, they don't protect, yeah. Yeah, I thought it meant like object. Yeah.
Okie dokie, pokey podies. I will stay right up here and answer questions till the next class comes in, but you may leave. Merry Christmas. Don't expect us always.